Okay. Oh, excuse me. Hello, good morning. Did everybody get a good night's sleep? Excellent. My name is Mark Rendle, and I've come a very long way to try and convince you of some things. This is a very kind of high-level talk, and it covers a lot of stuff really quite quickly. I'm going to talk fairly fast, and hopefully this is going to kickstart your brains for the rest of the day, so yay! If you come to my talk tomorrow morning, by the way, that's just stupid. It's just me being like silly and stuff. So come to it because it's going to be fun, but don't come to it because you want to learn anything. There you go, disclaimer. Now I can say what I like in that one. Right, but today, cloudnative.net. You can follow me on Twitter at Mark Rendle. You can go to my company website, which is rendlelabs.com, because I thought if Mitchell Hashimoto can create a company with his name in it, then so can I. Right, cloudnative.net. This talk is online now at a website called DeckHub.app. And if you go there, there's a search box, and you can type in cloud-native-net and press enter, and you will be able to follow along, and you'll see the slides appearing on your device as we go along. And if you log in with your Twitter account or your Microsoft account, you can ask questions, and they'll come up on this extra little screen I've got here, and I'll be able to answer them. And so you don't have to stick your hand up. Hands up, who doesn't like putting their hands up? Yeah. You can ask me questions, and then I'll answer them. And the really good thing from the organizer's point of view is it forces me to repeat the question, because otherwise I just go, no, and everyone else is going, what? So, yes. I think it's working. It was all working yesterday. We tested it yesterday. I had to do some horrible things in ASP.NET Core Security to get it working. Let's not talk about that. Turned out it was in the docs as well, so that was good. And this application, DeckHub, is all open source. It's on GitHub at github/DeckHubApp. And so everything I'm talking about, you can go and download the code and muck about with it. You can spin up your own instance. If you want to contribute and send me pull requests, that'd be super awesome. Anyone who can do CSS and come up with something better than a blue background, that would be really cool. Feel free to log in and do that. The privacy page isn't there yet, but I promise I won't sell your data to Facebook. So, what is Cloud Native? There's a Cloud Native Computing Foundation, which as far as I can tell is Google. And they have a definition of Cloud Native, and it doesn't mean building applications that only run on Azure. Okay, this is running on Azure, but it's running in a Kubernetes cluster on Azure, and I could just as easily spin up a Kubernetes cluster on Google Kubernetes engine, or Amazon Kubernetes service, or my own Kubernetes cluster if I enjoyed the pain of spinning up my own Kubernetes cluster. So Cloud Native refers to being able to run in the modern cloud world, the cloud world of platforms and services. So Cloud Native, according to the Cloud Native Computing Foundation, has 4 pillars. Cloud Native applications are composed of microservices. Those microservices are running in containers. They are consuming platform services for things like databases and caching and those kind of persistence concerns usually. And it's all about DevOps and continuous integration, continuous deployment, monitoring, and that sort of stuff. So we're going to go through these one pillar at a time, and you're going to get my opinion on all of them, because there doesn't seem to be any consensus, and my opinion is as good as anybody else's. It's taken me 30 years to get to that point, so don't try and take it away from me. Thanks. So why would you want to build a cloud-native application? What is better about building cloud-native applications in 2018 than building other kinds of applications? We're at a sweet spot now, particularly with things like Kubernetes and Prometheus and so forth. We've got some mature tools. The tooling for building this stuff is there and it's well documented and it's usable, and in a lot of cases it's just a flick of a switch on the cloud platform of your choice. So the tools and the ecosystem are actually at the start of maturity, let's put it that way. They're not mature, but they're not brand new and flaky either. Bits of them are flaky. But the important bits are there, and they generally work. Most importantly, if you go, this isn't working and what's gone wrong, you can usually go and do a Google query with the error message, and you will actually find out how to fix it, which is always a good thing. We have scalability. So if you build an application using these cloud-native principles, it's a very, very easy to scale that application. You can scale it up onto bigger hardware. You can scale it out onto more hardware. And so you have this flexibility of scale. And a kind of flip side of that is you can reduce the costs of running something. Because if you can scale very accurately and scale each part of your application independently, you can really minimize the amount of resource that you need to run the application. If you have a monolithic application and one bit of it is having to serve 1 million requests a second, but the rest of it is really just static, you have to scale up that entire application. And so everything that you run it on has got to be able to run the whole thing. If you break that down into little bits, then just the bit that needs to serve 1 million requests a second can be scaled up and out, and the rest of it can sit there and run on tiny little micro instances in AWS or whatever. Okay? So, Pillar 1, microservices, because it is illegal to do a talk in 2018 that is not about microservices. And that's great because no one knows what microservices are. And so you can just stand up here and go, I'm talking about microservices with HoloLens, and people can't argue with you. They just have, yes, you are. So things we can't agree on about microservices. How small should they be? Which, with a name like that, is really quite important. I have actually sat in meetings where people have, with a straight face, talked about, well, it's really more of a nano service. And kind of like, you don't know how small micro is, do you? But yes, so we're not really clear on how small they should be. We just know they shouldn't be big. That's the one thing we're all clear on. As to how small it can go, where does it become too small? And where are the boundaries? How do I decide whether this is 2 microservices or one slightly larger but still microservice? Where shall I put the brakes in to keep this a microservice application? Am I doing this right? And I think the answer to that is almost certainly no, because if I tell you yes, then you'll just get up and go and see a different talk. So I have my rules of thumb for what constitutes a microservice and how you go about building one. Fundamentally, it should be self-contained. Okay, it shouldn't need any other services. It shouldn't need data from other services in order to do its job. It might like to have data from other services, but it should be able to carry on running and doing its job without another service being there. If you have a microservice and every time somebody hits that, it hits another microservice, and if that microservice is down, then this microservice is down, those aren't 2 microservices. That's just one service that you've broken into 2 bits for no good reason. Okay, so microservices, as far as possible, should be self-contained. It's okay to say, can I get some more data from here? And if I can, then yes, we'll decorate some data or we'll augment the data from there. But it should be able to carry on running, ideally in splendid isolation. And if it goes down, it shouldn't take everything else down with it. Big part of that is that it should have its own data store. And what that means depends on the budget of your organization, really, because ideally what it means is it should have its own database running in its own rack server entirely to itself. But obviously, if you've got 1,000 microservices, you don't necessarily want to be going out and getting 1,000 separate SQL Server instances to run databases for all of them. So there's wiggle room in there. But the nice thing about this is if you build a microservice architecture, if you build these independent components, and yeah, you might have all your databases running on the same server. If you then decide that one of them is critical and the rest of them are just nice to have, then you can take the critical one and put that service's database on its own server with its own disaster recovery and everything else, and the rest of them can share stuff. Okay, so you're giving yourself flexibility. And one of the key points of doing this, because it's more complicated than building a monolith, but the trade-off is that it makes some things much simpler. Okay, so self-contained, their own data store, and ideally, if they're not there, your application should carry on running and providing as much business value as it can without necessarily providing 100% of the business value. Okay, so I'm going to go through the services that are making DeckHub.app work here, just to give you an example. Okay, so this is all written. Let me just check my slides. No. Right. Can everyone see the Explorer bit at the side here? Yeah? My God, you've got much better eyesight than me. Okay, so DeckHub has a website. Incidentally, the thing that I'm running to actually generate the slides on this machine is an ASP.NET Core 2.1 application, which is compiled with Core RT, which takes IL code and compiles it to static native code for the platform that you're running on. So this is an ASP.NET Core 2.1 application entirely contained in 127 megabyte deck.exe file, which is static. It doesn't have any external dependencies. You could take that and put it on any Windows box without any .NET installed at all, and it would just work. It's like Go. It's fantastic. And I did that by adding one file and one entry to CSproj. That's also in the GitHub thing if you want to have a look at that. That's pretty awesome. But no, so this, the application breaks down into, we have live. So live is the main website. That's where the CSS and the JavaScript and the HTML are served from. That's the page that you saw when you went to DeckHub.app, and that's the page where you typed in Cloud Native Net. Okay, so that's not really a microservice. That's just a website. When you typed in Cloud Native Net, if you did, I don't think anybody has yet because I'm not seeing any questions, or I'm just explaining everything really well. Very hard to tell from where I'm standing. When you type that in and pressed enter, it sent that off as a query to a /shows URL on the same website. That is actually a separate microservice, an entire separate website with MVC controllers and views and everything else. And that is running independently of the first thing. So that shows microservice is there as well. And that's what showed you the list thing there. And then if you're on the page for this show and you're seeing the slides go along as I move them along, then that's coming from that microservice as well. If you ask a question, you do that through a form that's generated by the shows service, but that question will then actually go to the question service, and the question service will persist it into the database, and it will add that question to a service bus, and then service bus will bounce it round, and it will go through a SignalR hub, and it will appear on everybody else's device, and it will appear on my screen here. That SignalR hub is running in this real-time service here, so that is just a SignalR hub. It contains SignalR on the server side, and it contains the bits of JavaScript that are necessary to make that work in your browser. Okay. We also have notes. If you're logged in, you can write notes alongside each slide. And then if I actually get my act together and build the bit where you can log back in and see the shows that you've seen, you'll be able to go back and review your notes. Haven't done that yet. Been too busy keeping myself up to date with the new versions of .NET Core every time they release one. But if you do create notes, then that'll go through the notes service. All right? And that is separate as well. The view that I've got on my screen here is the presenter view, and that is a separate service. And so that could go down, and I wouldn't be able to see the presenter view, but you guys could still ask questions, and I could probably figure out a way of answering them by just having the shows page open on my machine as well. And we have a slides service here, and all that does is when my client application here, when it shows a page, it grabs it as a PNG and it uploads it to the slide service, and the slide service serializes it into blob storage. Right now, the slide service, actually I'll dig into this and we'll have a look, because this is as simple. Did anyone come to Glenn's talk about APIs and microservices last night? So you saw very, very simple, very, very small, just a values controller. My personal opinion is the value controller is a bit of overkill. I just have a single piece of middleware. That's it for this service. And literally all it does is say, if the request method is get, then do something. Otherwise, if it's put, then upload the slide. Otherwise, if it's head, just return a thing saying how big the slide is. Okay, that's it. I don't really need a controller in here. And it meant I could leave out the whole ASP.NET Core MVC Razor library from that. So that keeps that nice and small as well. So those are my microservices that make up this application. Did I miss any out? Identity. So it's using ASP.NET Core Identity. It's using the built-in thing to link to Microsoft account and Twitter. Normally, you would just put that into the central website part of the application, but I didn't want to do that. I yanked the identity out of the core application and I put it into its own microservice, so that now runs independently as well. And so the website will keep running, even though you might not be able to log into it because something has gone wrong with the identity service, and that can be scaled independently as well. The identity service has its own database. The questions and notes service have their own databases. They are all running on the same PostgreSQL server in Azure, but I could split them out if I wanted to. I could rewrite the identity service to use table storage or Cosmos DB or something else entirely without having to change anything with the other two services. If the question service suddenly went nuts, I could scale that up without having to worry about scaling anything else up. So these things are all separate, and if the note service goes down or the question service goes down, the page will still render, but when it tries to download the little bit of JavaScript from the note service and the little bit of JavaScript from the question service, it won't be able to find them. And so the notes panel won't appear or the questions panel won't appear, but the site will carry on running and it will carry on working. So everything is isolated from everything else and everything is independent. What I'm planning on doing is coming up with an internal registry inside the server cluster, probably in Redis, where services can come up and go, hello, I'm here, and when you render this view, I would like to be included in that view. So here's the JavaScript that I would like you to include in that view. And so then I can deploy a whole new service and have it automatically integrate itself into everything that's already there without me actually having to change anything else. Do you guys have Amazon in Australia? Sorry, I don't know what you have Woolworths. And so I saw Woolworths, which used to be in the UK, but it went bust. And so and it was Amazon that made Woolworths go bust. So when I saw Woolworths, I thought maybe they don't have Amazon. See, thinking. But no, when you go to an Amazon product page, you see all sorts of things, reviews, other people who looked at this also like this other thing. There are no reviews from the Australian Amazon. Would you like to see some reviews and see what Americans thought of it? No, why would I want that? But, you know, it's there. When people have an idea for something that might be cool on the Amazon product page, they write it and they register it in this kind of internal registry, and these things just appear on the page, which is why they all load asynchronously, because they're actually being pulled in. People can add stuff into that product page without actually having to go to the product page code and make any changes. Right? It's why things come out in different orders sometimes. So I'm trying to achieve that as well. So we have a kind of thing that puts itself together auto-magically. So this is all running on ASP.NET Core 2.1. Some bits of it are running on ASP.NET Core 2.1 preview bits because I got them working and I haven't needed to do anything to them since, and so they're still stuck on those. They've been up since January. The identity bit is running on ASP.NET Core 2.1.4 because it wasn't working yesterday, and so I had to fix it and do horrible things to it to make it work. So everything's running on different bits of ASP.NET Core 2.1. This is another great thing about microservices. Tech moves fast. So my day job, I work on a big monolithic WPF application, 120-something projects in this solution, 20,000 unit tests. And at the start of this year, we migrated it to .NET 4.6.1. Yay, enterprise. And in order to do that, we had to test every single last grid box and data field and button and backend service and everything to make sure that it was okay to upgrade it to .NET 4.6.1. And we had to make sure that all our upstream libraries worked with .NET 4.6.1. It was an absolute pain in the backside, okay? If we'd broken... Not sure how you break a WPF application down into micro WPF applications. Pretty sure it's possible. But if you could do that, then you could upgrade it one bit at a time and just go, right, this bit's running on 4.6.1 now, and everything else is still running on 4.5.2. So I can do this. Some of the stuff that's in ASP.NET Core 2.2 preview looks pretty cool, but I don't necessarily want to trust Signal R 2.2 preview or 1.1 preview or whatever it is just yet. I want to kind of hold off. So I can update the bits of this that would benefit from 2.2, and if they work, that's fine, and I'll deploy them. I don't have to worry about upgrading everything and maybe breaking one bit of one service, okay? But at the moment, it's all pretty much ASP.NET Core 2.1. It's using PostgreSQL for all its data storage, but the questions and answers thing, I'm thinking of moving across to Cosmos DB, because that makes perfect sense. For each slide, there's a document in Cosmos DB which has got an array of questions, and the questions have got an array of answers. That's a document database. Seems silly to do that with a PostgreSQL database, and yes, I know Postgres does JSON. I have a Redis server that's running on the cluster. It happens to be on the cluster at the moment. I could move that out and use Azure Redis if I had $800 a month to spend on my caching. But Redis is being used for caching and also for shared keys. So data protection keys are being shared via Redis, and it's also doing some pub/sub stuff. And I'm also using Azure Storage and Azure Service Bus to send messages around and to store the slides. If I wanted to pick this up, so my slide service is hard-coded to use Azure Storage. If I want to make this application work in AWS, then AWS has Redis, AWS has PostgreSQL, AWS doesn't have Azure Storage. I could just rewrite the slide service and create a new version, a new alternative version of the slide service that talks to S3 storage and dumps the slides in there. And so at that point, we've got kind of microservices as dependency injection. I just change my Helm chart or whatever it is, and I bring it up in AWS with the S3 thing, and in Google Cloud with however Google Cloud stores blobs. I don't know. Okay. So communication between these. None of these microservices are talking directly to any of the other microservices. Sometimes that is a good pattern. Sometimes that is what you want to do. And you can use HTTP or you can use gRPC and have microservices communicate directly with each other. You use either some form of DNS or console, etcd, zookeeper, so that when a microservice comes online, it says, hey, I'm here, I do this, and this is my IP address and my port number. And then the other microservices use that to find it. I've built this so that everything kind of comes together through the browser interface, which works perfectly for me because I've got a browser interface. But if you've got a mobile application or a desktop application, that might not be appropriate for you. So you might want to look at having a manager service that talks to an API management service that talks to the microservices behind it. The key thing to aim for here, though, is that communication between microservices, as far as possible, should be asynchronous. So if a microservice is going to tell another microservice... I say microservice a lot in this talk. I've only just realized that. This is like the 8th time this year I've given this talk. I'm just going to say service. If a service wants to tell another service that something has happened, it should do that by putting a message on a bus. A lot of people would argue that if a service wants to ask for information from another service, it should do that by putting a request reply message on a bus and waiting for a reply and not really care about where that reply comes from. You see setups where you get one request actually results in 3 replies, and then the consuming service mushes those replies together and then sends them on to wherever it's going to. What I've got here is someone asks a question, and the question service puts that onto a pub sub thing so that everything else in the system can see that a question has just been asked. When a slide is uploaded, it tells the real-time hub that the slide has been uploaded and is now available, so the real-time hub can tell everybody's device that that slide is now available and it's okay to move on automatically on the people who are watching, and so on and so forth. So it's as much as possible communicating over buses and queues, might be RabbitMQ, ZeroMQ, Service Bus, SQS, whatever it is, okay? But asynchronous and no failure if something doesn't happen. You might want to sit there and spin for a bit, and you might want to say, okay, do this asynchronously by posting something on here with an identifier and then polling something else with an identifier until it comes back or 5 seconds have passed, whichever happens first. So yeah, asynchronous, undirected. I'm going to put a message on a pub sub bus. I don't know who's going to consume it. I don't know what they're going to do with it. If every single thing that happens in the system goes onto a bus, then it's very easy to add new behavior to a system without having to change the code that's posting that message. It doesn't have to know that there's a new thing it needs to tell. It just goes, this has happened. So that's kind of getting into event sourcing, but I don't know what event sourcing is, and I don't care. Don't tell Greg. So yes, so I'm using queues with Service Bus, and I'm using PubSub through Redis. Queues have the advantage where you can say at most once delivery, or at least exactly once delivery. And you can create a queue in Service Bus, and then you can create groups of readers off that queue, and one actor from each group will get that message read off that queue. PubSub is just everything needs to know that this has happened. There are 2 instances of the Service Bus running. So when a slide becomes available, both of them need to know that that slide is now available. So that's just PubSub. So you use different queues for different purposes. If everything can act on something, then that's PubSub. If you are going to update a running total somewhere, you don't want 2 things to update that running total because it'll go wrong. Okay, so this is what I'm using. Obviously, there are lots of other technologies out there. And at the end of the day, it is perfectly fine to say, yo, HTTP me this information because I want to stick it into this result that I'm sending out. But put a timeout on it, wrap it in poly, retries or circuit breakers or whatever it might be, so that if the thing it's asking goes away, it fails, and it fails reasonably quickly so that everything else keeps going at the same speed. So these are the parts here. We did that already. This is the deployment. So at the top there, you got your browser. That's the thing that you're in, watching my slides go by, going, my goodness, look what a marvelous presentation tool this is. I made this slide by doing it in PowerPoint and then presenting it and doing a screen grab and then dumping the PNG into my presentation. It's not cheating, shut up. Your browser is talking to an Azure load balancer. The Azure load balancer is sitting in front of a Kubernetes cluster, and it's using an Nginx ingress controller, and depending on what the first part of the URL is, it will route that request to different microservices within this setup, okay? And I'm about to show you how that works. So obviously, it's running in Docker and Kubernetes because everything that's anything is running in Docker and Kubernetes now, except Docker and Kubernetes. Actually, I think even Docker runs in Docker now. But anyway, so yes, it used to be that there were competing scheduling and orchestration platforms. There was Apache Mesos and Mesosphere. There was Docker Swarm. There was the new Docker Swarm that wasn't the old Docker Swarm and was completely different, worked in different ways, but was still called exactly the same thing, which wasn't confusing at all. And there was Kubernetes, and there was a lot of debate, and there were lots of little ones as well. And there was a lot of debate about which one you should use and which one was better for each purposes. And then this year, last year maybe, Kubernetes just won. So now, you have Docker. It was called Docker for Windows or Docker for Mac. It's just in the middle of a name change to Docker Desktop, but that's what you use on your machine, unless you're running Linux, in which case it's just Docker. And Microsoft provide Docker images for all the .NET flavors on different Linux bases. There are ARM64 and ARM32 variants. There are Windows Docker images, bless them. But you can get all of those from under hub.docker.com/u/Microsoft. And so it makes it very easy for you to build your ASP.NET Core application into a Docker image, push it to a registry, and do fun things with it. So let's have a look at how we do that. A couple of things. We've got Dockerfiles to start off with. So I will show you the Docker file for one of these. Let's do it for live. So we have a Docker file here. And so you can see here, this is still running off 2.13 release candidate 1, because I haven't needed to upgrade it yet. And with a Docker file, all you do is you say, use this base image. That from means use this as a base image. So this is Microsoft's image that has got the .NET Core 2.13 SDK installed on the Ubuntu Bionic base image, okay? So we get that, and we create and change into a /code directory, and then we copy the entire contents of the current directory, which is the solution level, into our working image. As Docker is building this, it creates container after container, and each container changes the underlying image, and then that is what the next container loads as its base image. And so we go through a series of steps and build up this container layer by layer, build up the image layer by layer. So then we copy everything into there, we change the working directory into the main CS proj directory, and then we just run .NET publish, send the output to a /output directory, configuration release, because we want this to run fast if possible. And then we have another from. If you used Docker in the past, but you haven't used it recently, that might seem confusing. This is called a multi-stage build. People would go through hoops to make their Docker builds as lean as possible, to make the resulting image as lean as possible. When we started out with this stuff, you would just use the SDK image, you'd put your source code into it, you'd build it, and then that would be what you released. You would send a Docker image out there into the wild with your source code on it. Yay. Maybe not a plan. So people came up with doing multi-stage builds where they would create one Docker file that would do the build and then leave an image dangling at the end of it. And then they would create another Docker file that manually mounted that image and copied the assets off it into a new image. And Docker saw everybody doing this and went, fine, we'll just build that into the Dockerfile syntax in the first place. So this second line down here, where it says from, oh, no. Shift V, there we go. So the top one, we're going from the SDK image. The second one, we're just going from the ASP.NET Core runtime image. That's got the ASP.NET Core NuGet packages pre-installed on it. And so we just pull that one down, and then we copy the output directory from the previous image onto this new image, which has just got our released DLLs inside it. And then we set the work directory, and we set the entry point so that when this container starts up, it will run .NET DeckHub live.dll. Okay? So this means the image that we're actually distributing is much smaller. The SDK image is about 2 gigabytes. The runtime image is only about 70 or 80 megabytes, and then you put your code on top of it, adds another 10. So you're under 100 megabytes for each of these images. The really important thing with Docker is that base image, that runtime ASP.NET Core Bionic base image, If you've got 15 microservices running on a single Docker host that are all based off that one image, it will only download that base image once, and then it will layer all of your application images on top of that same image. And it can do that because Docker images are immutable. So once it's become an image, you can't change it anymore. So we can reuse that same base image over and over again. So if you have one thing running, then that's your 90 megabyte image. If you have 10 things running, you've got that base 80 and then 100 on top of that, so you only got 180. So it's nice and small. And it's possible to make it smaller. If you want to see how to make these things as small as possible, Scott Hanselman's been blogging on how small you can make these. He's got it down to about 35 megabytes for a complete application, which is pretty cool. So, so that's a Docker file. And then when I'm working on this locally, obviously I want to have all these applications all up and running at the same time, and then I maybe want to attach to some of them with a debugger and set breakpoints and see why my note service isn't working or something like that. And so I want to be able to bring up all 9 of these services, plus a Redis, plus a PostgreSQL, just so I can test things locally, which I could just sit there and do Docker run. That would be annoying. I could put Docker run commands into a PS1 file or a CMD file, but then if somebody wants to contribute and they're running on Mac or Linux, that's not going to work for them. And so we have Docker compose, which lets you say, I need all these things to come up all at the same time, and I want them to be able to see each other, and I want to link between them and everything. So there's a Docker compose file at the top of this here. And you can see we've got quite a lot of YAML in here. Most of it's copied and pasted. Some of it's copied and pasted and then not edited, which causes very weird behavior when you accidentally spin up the note service but tell everything it's the question service and then wonder why you're getting 404s. But this brings up each of my images. It will build the image. So here's the presenter image here. And this says we're going to use this image, DeckHub/presenter 1.0 alpha 2. If you can't find that image, then build the Docker file that's inside this directory. Okay? We set environment variables. We are using an internal network so that these things can see each other using Docker's DNS service. And we also bring up our PostgreSQL and Redis and InfluxDB and Chronograph and all sorts of interesting things in here. Once this is done and I've got this right, I can just do Docker compose up, and that's it. My entire application comes up composed of one instance of each microservice, and then I can get on with figuring out why it's not working properly. I use this image here, traffic. Traffic is a reverse proxy, and it's not the best reverse proxy in raw performance terms. It's not as good as Nginx or HA proxy, but it is very good at knowing about Docker. And so you can say to traffic, you're running inside Docker, and here is how to interrogate that Docker, and then it will just watch the Docker daemon, and every time a service is brought up, it will say, have you got some labels for me? And if you have, then I'm going to route traffic to you. And so I have a domain called microstuff.io, which is set up with DNS records which redirect any request to microstuff.io or a subdomain thereof to 127.0.0.1. So I can go to https://microstuff.io/questions, and that would bring up the questions thing running in here. So I can use that as my my local development URL, and so can you, because it's there, and I can't get rid of it because it's booked for the next 10 years, and it's always going to point at 127.0.0.1. So yeah, go for it, use that. So traffic picks up things off microstuff.io, as you can see here, and then it looks at the labels on the other things that are in here. And so this says traffic front end rule. So this is the notes microservice. The host is microstuff.io, that's fine. Path prefix notes, and so anything that has the path prefix notes will get routed by traffic to this service here. Okay, so I get my microservice cluster running up for local development. That's fine. That's local stuff. Previously, I could have used that Docker Compose file with Docker Swarm, and it would have done something fairly similar. In practice, that never quite worked out. So in production, I want to run on Kubernetes, and there are multiple reasons for that, but primarily it's the most adopted, it's the most mature technology out there, it's the one that's got the ecosystem and the tools built up around it. But more importantly than that, it's the one that is provided as a first-party service by the three major cloud platforms. So Azure has AKS, Google has GKE, and Amazon will eventually get EKS out of its beta phase and start supporting it properly. And the best thing about all three of those is you don't pay for your control plane nodes. So a Kubernetes cluster consists of the control plane, which, if you want resilience, is 3 separate nodes all talking to each other over etcd and working together to manage the worker nodes, which is where your application itself is actually running. So if you wanted a resilient system that could survive one of the master nodes going out, you can't have 2, because if you only have 2 nodes, etcd doesn't know what to do because it needs a raft consensus, and you can't do raft consensus with even numbers. So you have to run 3 master nodes. And then you have to run worker nodes as well, and you want 3 to 5 worker nodes. So suddenly you've got like 8 nodes running, and this has got really expensive. AKS, GKE, and EKS all run the master control plane for you. So you're only paying for your worker nodes, which is a massive saving. So this is actually running on 3 burstable VMs in Azure, which have just got my worker processes running, and Microsoft are paying for my control plane, which is very nice of them and makes up for them taking my Azure MVP away. Which was what used to pay for everything running in Azure. It is possible to spin up your own Kubernetes cluster. Don't. Just don't. It's horrible. Just spinning up etcd, frankly, is beyond what I would suggest most people put themselves through. So yes, you can. If you have an ops team, that's their job now. If you have to run stuff on-prem, then go to your ops team and say, we need Kubernetes, just do it. And then once they've got that done, then your job's easy, and if anything goes wrong with it, it's not your problem. Yay, DevOps. So Kubernetes works on the basis of clusters and nodes. I have a single cluster. That cluster has 3 nodes in it. And then I create workloads that run on those nodes. And workloads are things that I need to happen. And at the simplest level, this is, I need you to run a container. But Kubernetes has lots of different kinds of workloads, and you can add your own workload into Kubernetes. So you can say, right, so I'm running Nginx, but you can also say I'm running Nginx as an ingress controller, and an ingress controller is another kind of workload that does something very specific and gets access to different parts of the system and so forth. And you can say certain workloads have certain permissions within the cluster, and they can bring up other nodes in the cluster, or they can bring up other pods in the cluster. Okay, and then we have pods. So Docker talks about containers. A container is essentially a single process. You can run multiple processes in a single container, but don't, because it's wrong. Okay, unless it's just launching a process quickly to do something which then dies again. That's okay. But really, a container is an isolation wrapper around a single process. Kubernetes works on the basis of pods, and a pod is at least one container, but it can be more. And this is quite often used for what's called sidecar containers. So you have your primary application container, and then you might have a Logstash sidecar attached inside that pod. Everything inside a pod can talk to everything else inside that pod over localhost. Nothing outside that pod can see anything inside that pod unless it explicitly says so. Okay, this is important because we're about to look at some Kubernetes files, and it's important to understand how those work. So to use Kubernetes, you need a Kubernetes cluster somewhere. If you have Docker Desktop for Windows or Mac, you can go into the UI for that, and there is a Kubernetes tab in the UI, and you can just turn it on. Yay, you now have a Kubernetes cluster. That's much easier than it was at the start of this year when you had to run Minikube, which involved doing terrible things with Hyper-V, if I remember rightly. You also need kubectl, which is a single self-contained executable written in Go, and you can install that using Chocolatey, or you can just go and grab it from the Kubernetes website and download it. kubectl is a command line tool that you use to talk to your Kubernetes cluster. You also need lots and lots and lots of YAML. There is just an insane amount of YAML in this world of cloud native and DevOps and everything else. Everything runs on YAML, which is the worst serialization format in the world, except for all the others. Apologies to Winston Churchill. But there is a lot of YAML. And we also have the ingress controller, which in Kubernetes terms is doing the same job as traffic was doing in my Docker Compose file, except Kubernetes supports different technologies can provide this ingress behavior. The one that most people use is the Nginx ingress controller. So we're going to look at the Kubernetes file for one of these services. So let's look at questions. So in here, I put a kube directory into each of my service directories. So the YAML for running it in Kubernetes gets checked into source control along with everything else. Okay. So here is my deploy.yaml file. And I have got, so each entry in a YAML file for Kubernetes will have an API version, which tells kubectl which API you want to be talking to with this data. It will have a kind, which is like type. So this is a deployment. We have metadata about it. So the name of this deployment is questions. It's in a namespace called DeckHub. Kubernetes supports namespaces. If that namespace doesn't exist, then this won't go up. You create a namespace using another one of these YAML files where kind is set to namespace, and then metadata name is DeckHub. Okay? This means that you can have a single massive Kubernetes cluster, and you can run things for multiple teams in separate namespaces, and they can't see each other at all. So you've got it's almost like the private internal protected stuff inside C# or something like that. So this is running in a DeckHub namespace. And then I have my spec, and this is essentially the container part. So I want 2 instances of this running at all times. This is a desired state configuration thing. If you don't know what desired state configuration means, it means you set up some data that says this is what this should look like, and then it is the responsibility of the system to achieve that state and maintain it. Okay, so I'm saying there should be 2 replicas. Once I've told Kubernetes this, it will just keep itself busy making sure there are always 2 replicas. Something goes down, brings up another one. I have a template for it. I'm putting some labels in here, and I'm going to set the app label to questions. And then I have my pod spec here, and my containers. I want one from this image. This now has to be pulled from an online Docker repository. I use the Docker Hub. These are all public images on the Docker Hub, so it doesn't cost me anything. But you can use Azure Docker repository or an on-premise one. The Docker repository runs in Docker, so it's quite easy to get going. And then I have various environment variables. So I have my runtime path base. This is the thing that internally in ASP.NET Core 2.1 says every request you get is going to be prefixed with questions, so ignore that bit. Okay, you'll see the code for that if you go and dig through the code for the services. Where's my Redis host? It's just running on Redis because it's another node in the cluster. I've got my app metrics InfluxDB server, which we'll look at in a bit. And then I've got my connection strings. And this is another neat feature of Kubernetes. So we're always worried about where are we going to put our connection strings because we don't want those to leak. If you've been doing ASP.NET Classic, that's just weird. For any length of time, you'll know that the place you put your connection strings is in the connection string section of web.config. You stick them in there unencrypted. What could possibly go wrong? Well, go and Google web.config and see how many you can find with people's database connection strings in them. No, we want to put them somewhere no one else can see them. And so we stick them into secrets. Kubernetes supports secrets as a first-class thing, and secrets are namespaced. So only things in the DeckHub namespace can see things in the DeckHub secrets namespace. So I've created a secret called questionsDB, and that's got a value in it called connection string, and that's encrypted by Kubernetes, and I stick it into an environment variable in here, which means It's never persisted unencrypted anywhere. It's just gone into memory in this machine. Okay, I'm also going to expose port 80, which is what ASP.NET Core is going to be running on in here. Then I have a dash dash dash, which is a section break in a YAML file, and then I have another component in there. This is a service. So this is saying, within this Kubernetes cluster, I am available, I am a service, I do a thing, and this is where I do it. And so the kind is service, the name is questions, namespace is DeckHub. You can find this service on port 80 from any other machine. You can find it using the questions name. So you can just do http://questions and you'll hit it. And we have session affinity client IP, which means that it's sticky sessions, basically. So the load balancer will see this and then say, right, so once a client has hit this particular instance once, I should try and route all subsequent ones to that client, and it will do its best to do that. That's very important for SignalR, which now requires sticky sessions or some serious gymnastics if you want to have people bouncing around. And then we have our ingress, which is where we've got an Nginx ingress controller set up. There's a Helm chart for that. Helm deploy Nginx, nice. Once that's up and running, then we create an ingress component, and that says, hey, Nginx, I want you to point to this, and we've got the host, deckhub.app, the path is questions, route any requests that start with questions to this service on this port. Okay? So that's getting it running in Kubernetes. Now, quick tip. Who's using ASP.NET Core at all, or just ASP.NET with traditional entity framework? So entity framework users, EF Core users, people who don't like putting up their hands. Good. With traditional entity framework, you would start up your application. Most ASP.NET applications, mostly they're running on-prem, and they start up and you say ensure database. And it goes off and it makes sure that the database migration has been run, and then your application carries on starting, which is fine. In EF Core, if you say ensure database, it will go off and make sure that migrations have been run. Doesn't create the history table. So when you try and run the next migration to upgrade it, it'll just go, no, I don't know how to do that because I haven't got any records of what's been done so far. So what you have to do is do update database, and then catch the error that says this database has already been migrated, what do you think you're doing? So that's fine, we can do that at startup as well. Except in a real sort of business enterprisey type environment, my replicas wouldn't be 2, my replicas would be 5 or 7 or 9, depending on how big this was. And you'd be amazed how symmetrically these things come up. So I've got 5 services, and they all come online at the same time, and they all hit that line in my startup code that says update database. And they all go and look at the database and the migrations table, and they all say, oh, look, the migrations haven't been run, and they all start trying to update the database at the same time. And everything catches fire, and you're fired, and you have to go to London and work in a bar. That's not good. So I came up with a pattern, and I shared it with Julie Lerman, and she thought it was quite a good idea, so I'm going to stick with that, where I have my EF Core context and model classes go into a net standard library, which is just a data library. And then I have a console application just called migrate, which literally just does one thing. And it does it so often, and I used this so many times. I put a NuGet package up called migrate Rendle labs.entityframework-core.migrate helper, and you pull that down. You put a design time context factory into your application, and you say await new migration helper.try migrate. And so I can spin up 15,000 instances of my actual web application, my microservice, and I can spin up 1 instance of my migrate service, and then I know that it's only going to run once, and then it will go away and not bother anybody ever again. And if I go into my cube thing here, this is another kind of Kubernetes workload. This is a job, and a job says start this container, wait till it stops, and then don't run it ever again. Don't use up my valuable resources. And so this runs from my migrate console application. I have a Dockerfile.migrate to build the image and push it up. And then I just have my secret connection string, which goes in there. And so that loads up, migrates the database. So I run this, and then I run my deploy immediately afterwards, and everything comes up, and I keep my database sane, and I keep my migrations in line, and everything else. Okay? So the next pillar is monitoring and metrics. So you've got thousands of things running by this point, and it's very difficult to keep track of that. And you've got lots of data points potentially coming out of there. How fast is it running? How many requests is it serving? Is the CPU overheating? What the hell is actually going on anywhere in this stack, which is now being maintained by 15 separate teams, none of whom ever talk to each other, even when we buy them pizza. We don't know why. We think it's something to do with developers. But yeah, what's going on? So it's very important once you get into this world to start putting code in for monitoring and logging and everything else. So, useful tools for that. Prometheus is extremely good for monitoring your Kubernetes cluster. Kubernetes will just dump data out to Prometheus for you. Influx data, InfluxDB is very good for when you're pushing metrics out, when you're saying, this has happened, there are 15 of these, this has gone wrong, whatever it might be. Though both of those are for metrics data, so basically numbers. Just numbers that you can then chart and make pretty dashboards and everything else. Elasticsearch is great for logging. There are also things like built into the cloud platforms, CloudWatch and Application Insights and Analytics and so forth. There's also something that I really like called Containership, which I will show you quickly. The reason I like this is that it's free for developers. But with Containership, you can just go in and you can add a cluster to your Containership login. And so in here, I can see all my services running. I can see that I've got some still running from when it was called Slidable, which is interesting. But I can go in and I can look at my identity service, and I can drill down into here, and it's pulling the Prometheus data, and it's just creating this chart for me here, so where I can see memory usage and CPU usage and lots of other things. And then I can drill down and I can see what's happening in a pod here, and I can drill down to the container in the pod, and I can actually see the logs that are coming out of there, because it's just logging to console, and that's getting picked up by Kubernetes and piped through to Containership here. So that's pretty cool. I also have metrics, and the metrics are going out to an InfluxDB database, and I'm charting that with Grafana, which is the standard sort of dashboarding tool. And this is really nice. This has got lots of information. I can see my throughput, not very many requests a second. I can see my error rate. I can see my AppDex score, which is how well is this running from the user's point of view. That combines lots of statistics and gives you a score out of 1. I can see response times and error rates and lots of other things, and I can see how many milliseconds it's taking for each of the different endpoints in the application and everything else. That is done using a library called AppMetrics for .NET, which is based on the Java library of the same name. No, Java's version is just called Metrics, I think. But AppMetrics is really, really nice, and it's incredibly easy to drop into your application. If I go into here and go into questions and program.cs, so there we go. That's one part of it. In my web host builder, I say web host create default builder, use standard metrics, use startup. That's it. I've turned on metrics in this application now, and then in my startup code here, I just have to go into my I've got services, add MVC as normal, set compatibility version, add metrics to MVC. That's going to register a bunch of global filters and so on to actually track requests as they go through the system. And then in my, yeah, no, that's it. No, he took that bit out. You don't have to do that anymore. The really nice thing with AppMetrics, right, this lovely Grafana dashboard that I've got here, he created that. The guy who does this is Al Hardy, who I believe lives down this way. And he created this dashboard to represent the metrics that the library produces just out of the box. And you can import this dashboard by going to Import Dashboard and typing in a number. It's a 4-digit number that you get off Grafana Labs. So you can have this, and then you can like go, this is what I'm doing working from home this week, boss. I'm going to add metrics to all our applications and create this dashboard. And you just do it on Monday morning, take the rest of the week, go surfing. Or do whatever you do with your time. So platform services, you don't want to be running these inside your cluster, because things that run in Kubernetes clusters are generally ephemeral, so don't run anything important in there for the most part. So databases, SQL Server, PostgreSQL, whatever, you want to consume those as a platform service. You want the ops guys to set those up. And you can just have them on demand. Blob storage, messaging. If you want persistent cache, if you actually need a durable, resilient cache, so my Redis that's running inside the cluster, if that goes away, everything carries on working, it's just a bit slower. If you need a proper, resilient, persistent cache, then use something like Azure Redis or AWS Redis cache or whatever on top of that. And then for DevOps, so you all know what DevOps is: continuous integration, continuous deployment. It's a guy sitting on a toilet eating tacos. And I couldn't find an image for that, sorry, because you know you want that at 10 o'clock in the morning. But yes, if your entire build and everything can be done inside that Docker file, then you can just use DockerHub. I've started using Azure Pipelines, which just popped up. Started using it yesterday, and it's really, really good. Really, really easy. You hook it up to a GitHub repository, you write a bit more YAML, and then you've got things going through to your Docker registry, and it's pushing into there. You can also GitLab, if you use GitLab on-premise or the cloud version, that's got an integrated pipelines process. That's really nice as well. And obviously you can run self-hosted, TeamCity, Jenkins, and everything else. The key point is when you check in some code, it should be pulled out somewhere, it should be built, some automated tests should be run against it. If it passes those tests, and if you're feeling particularly DevOpsy, then that release should be tagged, it should be upgraded, and it should go on to the next process where it gets automatically deployed into production. That's DevOps. It's a whole other talk. I'm sure there are plenty of people here who are ready to talk to you about it. That's it from me. If you want to download this code and play with it and see how this actually works on the inside, go to github.com/DeckHubApp. If you've got any questions, or if you want to see the core RT thing, which is pretty cool, I'm around the conference for the next couple of days. Come find me, come talk. I like talking to people. I hope you have a great day. I hope you enjoyed this, and I will see you again sometime. Thank you.